All right, today we are doing 1-2 in pre-calc, which is analyzing graphs of functions and relations. Today's date is today. Our objective is to use graphs of functions to estimate function values, find domain and ranges, find y-intercepts and zeros of functions. So we got a lot going on today. So first of all, we want to look at our domain on this one. And domain is what is our x. What is x in this one? So look along that axis. And it looks like x is going from 0 to 12. So I've got that highlighted because all along there, I've got values of x. I don't have anything going on past a value of 12. So it looks like my domain is going from 0 to 12. And it is including both of those numbers. So I'm going to use function notation, which we did in our last section. It is including 0. It's going to 12. And it is including 12. So that would be my answer for my domain. On this one, we want to look at our domain. We're also going to look at the range, the x-intercepts, the y-intercepts, the zeros, and figure out f of 3. So we got a little bit more going on this one. So first thing, let's take a look at that domain. That's our x values. Well, I've got an arrow here. So that means that it's actually going on forever and ever. Oops, we did not draw that arrow very well. So that is going on forever and ever in the left direction and in the y direction. So if I were going to show that as function notation, it's going from negative infinity to positive infinity. So it's going to be parentheses, negative infinity to positive infinity. So now let's take a second and look at our range. Our range is our output or our y values. What is y in this scenario? So I look, and I'm going to use highlighter this time. Let's use the green highlighter. Looks like my lowest y value is about a negative 1,000, and then it's got y values that go all the way up, and again both arrows are pointing upward, so that's going to infinity. So if I wanted to write that, it's my smallest is, and I'm going to need to use a bracket because it includes negative 1,000, and it's going to positive infinity. And again, I'm looking at my y values, or my y axis on this one. What is my lowest y value? What is my biggest y value? And this is continuous, so it's including all of those values in between. X-intercepts, that's where it's crossing your x-axis. So we're touching it. So right there, negative 2, 1, and 4. Negative 2, 1, 4. My y-intercept, where is it crossing my y-axis? Right there at 1,000. My zeros, well, my zeros are the same as my x-intercepts, so negative 2, 1, and 4. Now we want to go ahead and find our f of 3. So that's asking when our input is 3, what is our output? So right here is our input of 3. I go down, and we might have to estimate a little bit on this one, and that's okay. I'm going to say maybe negative 600. I'd probably give a little bit of leeway on that based on how you interpret that. It's hard with that scale between negative 500 and negative 1,000 to get something super accurate without any hash marks. So if I'm going to say negative 600, you might be slightly different, but as I said, I'd give leeway on that one. All right, what I would suggest you do is hit pause. Try this one on your own. Notice there aren't any arrows that are saying that it's going on forever and ever. And hit pause, try these on your own. And when you are done, check your answers, hit pause again. All right, the domain on this is from -4 to 7, and there's no open dot. It includes everything there. The range is from -2 to 6. My lowest y value is -2. My highest y value is +6. My x-intercept is -3. My y-intercept is +3. My 0 is -3, and f of 3 is 5. So when x is 3, y is 5. All right, take a second, pause, try this one on your own. All right, the domain on this one, you got that point right there, that's my smallest x value, that's -5, and that is going towards infinity to the right, so from -5 to infinity, and you need to use parentheses on both of those. My range, my lowest y value is -2, and it's going up towards infinity, so -2 to 8. It's crossing at -3, touching at 4, so my x-intercepts are -3, 4. My y-intercept is 4. My zeros are the same as my x-intercepts, and when x is 3, y is 4. Okay, on this one, we're going to go ahead and find that y-intercept algebraically. We're not given a 0 on this one, or a graph on this one. So x equals 0 to find the y-intercept, because when it's crossing the y-axis, your value of x is 0. So all you have to really do is plug 0 in for x, which is really a piece of cake. And you get -4 over -1, which is 4. Very easy to do. If I'd been asked to find the x-intercept, I would have let y equal 0. All right, symmetry. Symmetry is, do both sides equal each other? So testing for symmetry, you'll want to have these down in your notes and be familiar with them. If something is symmetrical on the x-axis, that means if I folded it along the x-axis, both sides would equal the same. You're going to substitute -y for y. If I wanted to test for symmetry in the y-axis, substitute -x for x. For the line y equals x, you interchange your x and your y around. And for the origin, you're going to take -x for x and -y for y. And does an equivalent equation result? Do you end up with what you started with? Okay? You can have different types of, or multiple types of symmetry. But these are the main ones that we're going to be testing for. So let's go ahead and do an example. So x minus y squared equals 1. So let's go ahead and test for x-axis symmetry first. So in that case, I'm going to take out I'm going to substitute -y for y. So I take out my y, take out my y, put in -y. So I'd have x minus -y squared equals 1. Simplify that down and I get x minus y squared equals 1. Well, did I end up with what I started with? Yeah. So we are going to go ahead and put down x-axis as one of our types of symmetry. So we need to go ahead and test for them all. I'm going to erase that because we're going to run out of room otherwise. Now, let's go ahead and test for y-axis. So in this case, I'm going to take out the x and put in -x. I'm going to get negative x minus y squared equals 1. Well, that is not what I started with. Those are not equivalent. So I would have to say no to the y-axis. I'm not going to put that down. So let's try for symmetry over the line y equals x. In that case, I'm going to interchange my x and my y. So I would have y minus x squared. Well, again, I'm not ending up with what I started with, so that would be a big no. And symmetry about the origin. I'm going to make two substitutions, negative x for x and negative y for y. So take out the negative x, or take out the x, put in negative x. Take out the y, put in negative y. And I'm going to be left with negative x minus y squared equals 1. Well, I'm not going to start with what I'm not ending up with what I started with, so that one would be no. So the only type of symmetry I have here is over the x-axis. Take a second and pause and try x times y equals 4 on your own. When you are ready, hit the pause button and check your answers. All right, when I do this, on the first one, I take out the y, put in negative y. So that's a no on the x-axis. To test for on the y-axis, I take out the x, put in a negative x. Again, that's going to be a no. For the line y equals x, you switch your x and your y around. And when you simplify it, yeah, you end up with what you started with. So that's a yes. And about the origin, you take out negative, you put in negative x for x, you put in negative y for y. The negatives kind of cancel each other out because a negative times a negative is a positive. So there is symmetry about the origin. All right, functions that are symmetric with respect to the y-axis are called even functions. Functions that are symmetric with respect to the origin are called odd functions. That is something to put into the memory bank. All right, hope you enjoyed.